Hey everybody, we are going to look at section 4.3 today, which is angle relationships within a triangle. All right, so the first thing that we're going to look at is our triangle sum theorem. Okay, our triangle sum theorem basically says that if we take the measure of all three angles in a triangle, then they're going to add to 180. Most of us kind of are already aware of this, but just a reminder in case you either haven't heard it before or it is new, that all of your angles in a triangle are going to add up to 180 degrees. All right, so let's take a look kind of at an example here. So we have that the map of France, commonly used in the 1600s, was significantly revised as a result of a triangulation land survey. Diagram shows part of the survey map. We want to use the diagram to find the measures of our angles. So the first angle we want to find the measure of is angle NKM. So here's N, here's K, here's M. So here's angle NKM right here. This is the one we're looking for right in this corner here. Okay? So I see that I have the measure of angle M and the measure of angle N. So if I look at just this piece here, I have this triangle, all but one of the sides, or one of the angle measures in this triangle right here, this blue one. So what I'm going to do is, again, just like we just said, I know that all of the angle measures are going to add to 180 degrees. So the measure of angle NKM is going to be 180 minus my two angle measures. Angle N was 48 degrees and angle M was 88 degrees. Okay, so we're going to subtract both of those from 180, and we're going to get that the measure of angle NKM is 44 degrees. Okay. Next, we're going to look at the measure of angle LJK. LJK is this angle. Oops, JLK. JLK. I was like, they just gave that one. JLK is this angle right here. This is the one we're looking for. Okay. Now, what I want you to notice is we already said that this angle was 44 degrees, right? So what we're going to do is we're going to look right here and note and see that I can find this angle right here. Okay? Because LKN is a straight line. So what I'm going to do is I'm going to start by finding the measure of angle JKL. Okay? So the measure of angle JKL is going to be 180 minus 44 minus 104. Okay, because that's what's missing right here. Because again, if I just look at those three, I know that this is 104 here, and this is 44 here. Do you see how all of these make a straight line? So they are going to be supplementary. All right, so when I do 180 minus 104 minus 44, I'm going to get that the measure of angle JKL is 32 degrees. So this angle right here is 32 degrees. Now from there, I can find the measure of angle JLK, which now I'm going to take and look at this triangle here, okay, to find that angle measure. So I'm going to do 180 minus 70 minus 32, and that is going to give me 78 degrees. So the measure of angle JKL, or JLK, I wrote it backwards here, my apologies, this is JLK. So the measure of angle JLK is 78 degrees. So again, if you have any questions on that, go ahead and write that down on your notes now. Okay, so what we're going to get new today, we've talked about postulates. Okay, a postulate is something that we assume is true. We cannot prove that it's true. Okay, we have talked about theorems. Theorems are something that we can prove are true. Well, now we're going to get one more type, and that's going to be a corollary. A corollary is kind of like a mini theorem. It is a theorem that comes directly from a theorem that we've done in the past. So what we're looking at is we did the triangle angle sum theorem, which said that all the angles of a triangle add to 180. Okay, so a corollary to that is that if I have a right triangle, then my two acute angles are going to be complementary, because let's think about that for a second. If I know that one angle is 90, okay, if I do 180 minus 90, then that is going to equal 90. So in this case, I would know D and E need to add to 90, because 90 plus 90 is 180 degrees. All right. Also, an extension of that theorem, so our next corollary, is that the measure of each angle in an equiangular triangle is 60 degrees. So what I can do is, I know that again, it's 180 degrees for all three of them. If they're all equal, I do 180 and I divide it by 3, and that's going to give me 60 degrees. So each angle in an equiangular triangle is 60 degrees. All right? So let's look at an example. Okay, I have one of the acute angles in a right triangle measures 22.9 degrees. So since it's a right triangle, remember, I know that one angle is going to measure 90. Okay, what is the measure of the other acute angle? So basically what's going to happen is, if I sketch this right triangle, pretend that let's do this, and actually get like a nice triangle. Here we go. All right, so if I sketch this triangle, I'm going to get that one angle here is going to be 90 degrees, and the other angle is going to be 22.9, and I'm looking for this angle. But remember, the corollary we just did says that those two angles are going to be complementary, so they will add to 90 degrees. So all I have to do is take 90, and from that subtract 22.9. And that is going to give me 67.1 degrees. Now, could you say 180 minus 90 minus 22.9? Absolutely. Okay, that would work just as well, because you know two of the three angles. This just saves you a little step. All right, and that's pretty much what corollaries do, is they just kind of save you a little step here or there. So any questions on that? Go ahead and write it down now. Okay, let's take a look at some vocabulary for a triangle here. When you have a triangle, everything inside the triangle is on the interior. Everything on the outside of the triangle is in the exterior. So that means that I have interior angles. So these angles are all inside the triangle. So angles 1, 2, and 3 are all interior angles of a triangle. Okay, here's some new vocabulary. If I take one of my triangle sides and I extend it beyond the triangle, okay, the angle that is formed by that extension and the side of the triangle is called an exterior angle. So when we look at exterior angles, okay, I can have one at each angle. This right here is an exterior angle. This right here is an exterior angle. And this right here is an exterior angle. Okay, so we will look at one exterior angle at each vertex of our triangle. Okay, it doesn't matter which side you extend, but I can extend either one of them to get an exterior angle. So for example, instead of extending this side, I could have extended this side and had this be an exterior angle. It's going to be the same. It's not going to matter which one you pick. Okay, so there's a relationship between the exterior angle here and what we call remote interior angles. Okay, let's think about this for a second. If you're sitting at home and you're watching TV and you don't feel like getting up to change the channel, which we really don't have to do anymore, but think about the old time TVs where you actually had to like get up and turn the dial. I don't even know if you guys know what that is. But you don't want to go get up and push a button. So you use a remote, okay? A remote is something that you use when you can't touch something. You're too far away from it, okay? So that's what I want you to think about when we talk about these angles. So angle 4 is my exterior angle. Angles 1 and 2 are the two angles that are not adjacent to angle 4. Okay, 3 and 4 are adjacent because they share a side. All right, but angles 1 and 2 do not touch angle 4. They are not adjacent to angle 4. And they are interior angles in the triangle. Okay, so 1 and 2 are remote interior angles to angle 4. All right, again, because 4 does not touch them. If I were to add the measures of angles 1 and 2, that would equal the measure of angle 4. And that's what our exterior angle theorem says here, is that if we add 1 and 2, it will equal the measure of angle 4. Okay, here's why. Let's take a look at this for a second. We know 1, 2, and 3 are supplementary, right? Because they form a triangle. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180, right? Now, let's take a look at this. I have angles 3 and 4 here. They are a linear pair, so I know that the measure of angle 3 plus the measure of angle 4 is also equal to 180. Okay, so from here, remember our transitive property, or we can substitute, since they're both equal to 180, I can say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals, now 3 plus 4 is also equal to 180. So I'm going to say measure of angle 3 plus, I'm going to run out of room, measure of angle 4. Okay, if I subtract the measure of angle 3 from both sides, these will go away. And look what I'm left with. I'm left with measure of angle 1 plus measure of angle 2 equals the measure of angle 4. So that is where this comes from. Okay, it's because these are a linear pair and they are supplementary, and because angles 1, 2, and 3 are also going to add to 180. All right, so let's take a look at what that looks like. All right, so I have 126 is my exterior angle, and then these two angles here are my angles that do not touch my 126. Okay, so what's going to happen is my two remote interior angles, so H and J, okay, are going to H plus measure of angle J. Those two are going to add to equal the measure of angle FGH. Okay, so what we're going to do here is just plug in what we know. We know that the measure of angle H is 6x minus 1. Measure of angle J is 5x plus 17. And the measure of angle FGH is 126 degrees. So combine your like terms here. I'm going to get 11x plus 16 is equal to 126. Well, I'm going to subtract 16 from both sides and get 11x is equal to 110. And when I divide both sides by 11, I'm going to get that x is equal to 10. Now, we want to go back and look at our question. I want to find the measure of angle J. So J is 5 times x, well, we just said x was 10, plus 17. So 5 times x is 50, and 50 plus 17 is 67 degrees. So the measure of angle J is 67 degrees. Okay? So if you have any questions about that, go ahead and write that down now. All right? Let's take a look at example 4 here. We're looking at what is called the third angles theorem. So what that means is if I know that two angles are congruent here and another pair of angles are congruent here in two different triangles, then the last angles have to also be congruent, because if you think about it, again, they're all adding to 180. So like if this is 50, I'm going to subtract 50 from 180. If this is 60, then I'm going to subtract 60 from 180. And I'm going to be subtracting the same numbers in both triangles. So that's going to leave me with the same measure. So let's just say, you know, this is 50, this is 60. That would make this 60, this 50. And you don't have to write the numbers in on your notes. It's just for helpful purposes. So 50 plus 60 is 110. 180 minus 110 is going to be 70 degrees. Over here, 50 plus 60 is 110. 180 minus 110 is 70 degrees. So we're getting the same number on both of these, because when we subtract them from 180, it's going to be the same. All right, so that's what this theorem is saying, is that if we know two pairs of angles are congruent in two triangles, then our third pair is the same. So if we look here, I know both of these are right triangles, so that's one pair of angles congruent, because remember we have that theorem that says that all right angles are congruent. I also know angle A is congruent to angle D. So I want to know, or so from here I can say that angle C and angle F are going to be congruent. So I can set them equal to each other. So I'm going to say 3y squared minus 72 is equal to y squared. So what I'm going to do here is I'm going to subtract 3y squared from both sides. I'm going to get negative 72 is equal to negative 2y squared. Okay. I don't want a square root until I have a coefficient of 1. So the next thing I'm going to do is I'm going to divide both sides by negative 2. So then I'm going to get 36 is equal to y squared, which from here we need to square root both sides. So 6 is equal to y. Again, we found y. We need to find the measures of angle C and F. So the measure of angle C is just y squared. Okay, and we said that y was 6. So that means that the measure of angle C is going to be 36 degrees. All right, so there's 1. Then from here we want to find the measure of angle F, and that is 3y, which is 6 squared, minus 72. So again, 6 squared is 36 times 3 is going to be 108. Again, remember to square the 6 first. We do not do 3 times 6 is 18 and then square 18. Okay, we square 6 first to get 36, and 3 times 36 is 108. So then when we do 108 minus 72, I'm going to get 36 degrees, which they should be the same because they should equal the same. All right, so that is kind of like your self-check there. So if you have any questions on that, go ahead and write those down and we will take care of those questions in class. I hope you guys have a great day and I'll see you later.